Hello, everyone, and welcome to this edition of 5G Blitz Week presented by Fierce Wireless. Great to see so many of you joining us this morning or afternoon, depending on where you are. My name is Alejandro Piñera. I'm the Senior Director here for Conference Planning at Fierce, and I'll be your host today and throughout the week. Now, before we get started, as always, a special thank you to our sponsors today, Ericsson, Robin, and Viavi Solutions. Well, we have a packed agenda for our opening session today where we'll be talking about 5G RAN and the state of the market. Where are we and where are we going? Soon we'll be hearing from Paul Challoner from Ericsson. He's a good friend and old speaker here from Fierce. I'm sure a lot of you are already familiar with him and looking forward to hearing his thoughts. Following his talk, we'll have a 45-minute live panel hosted by Chris Pearson from 5G Americas, and he's joined again by Paul Challoner from Ericsson, Mehran Hadipur from Robin, and Neil McRae from BT. Following the live panel, we'll be having our closing partner keynote by Same Yamani, CTO at Viavi Solutions. As always, we welcome and encourage your input and participation in the session. You can do so through the chat function just on the left-hand side of the screen, or if you'd rather send a question straight to our speakers and our panelists, you can do so using the Q&A tab, and they'll receive it and hopefully get those involved in the discussion. All right, well, that's enough from me now. Let's hear from the experts. I'm going to hand it over to Paul from Ericsson. Paul, over to you.
Thanks, Alejandro, and hello, everybody. So my mission today is to talk about 5G RAN and the state of the market. Where are we today and where are we going? To talk a little bit about 5G, 5G Advanced, and then as we start the journey towards 6G. But I thought we'd start with a look at a 5G showcase event. And I picked the Super Bowl of 56 that happened a few weeks ago in LA. And why are we going to talk about that? Is because it's a good example of the 5G capabilities brought to bear, a well built out network and the capabilities that can be extended to many different areas, use places and use cases. And so I thought I'd focus a little bit on what we're able to achieve as an industry. So first of all, this event was held in LA. It was the Super Bowl against the Bengals against the Rams, and it was an investment made by operators about $300 million to equip this with state-of-the-art 5G capabilities. And that represents about something like 600 or so radios, 5G radios deployed that have mid-band capabilities, so 2.5 gigahertz, 3.7 gigahertz C-band, plus millimeter wave, so that's 28 and 39 gigahertz. So all the different elements of 5G installed in the stadium, the SoFi Stadium here in LA. And if we look at what we managed to achieve, the 70,000 fans that participated in the game, they generated about 33 terabytes of data. Now, about a third of that was 5G. And so that is effectively controlled by the number of devices, device ecosystem penetration, and the subscriptions. And if we compare that to Wi-Fi, there's about 2,500 Wi-Fi access points. So there's more cellular data than Wi-Fi data used. But if we look at the fan experience, like how was that? So they would experience hundreds of megabits per second of a 5G capability in the downlink. And I think the record was about 4 gigabits per second. So really terrific throughputs. But what did they do with that? Well, there's a lot of AR, augmented reality, and virtual reality experience. So you could really interact with the game. There was 7 different player views that you could interact with, and you could play games on field with your devices. But what was kind of astonishing is that this was an interaction with 2 billion other Snapchat users using AR around the world. So 2 billion interactions. So really tremendous, rich set of experiences, and really kind of a nascent metaverse if you think about it. So that's really an example of what 5G can do and where we are today with current commercial equipment. So that was a good data point. But one of the questions today is, what about monetization and how do I make money out of 5G as an operator? And so I divided this into sort of a 6-step recipe, if you like, of what's happening around the world in 5G. Step 1 is around getting that blanket of coverage out there, typically on a low band. It's really capturing that 5G icon, and as a first mover advantage, encouraging subscribers to come to your network, or as a fast follower to equalize the playing field in terms of 5G capabilities. The next step is to add on extra capabilities with mid-band or high band. So that's more coverage, more capacity, and high band really gives you that experience layer as well. And so how do you monetize that? Well, originally we thought you could charge extra for 5G. That's not been proven to be the case. So in reality, what it becomes is an exercise around moving people to different parts of the billing plan. So moving people up to premium plans. and using 5G as the attraction to do that. And that allows arresting decline in ARPU or increasing overall ARPU. The next step really is fixed wireless access. And this was one of the first use cases of 5G when you think about it. And so in the US, for example, it's about 130 million households. And even if you exclude all the fiber fed and highly served areas, there's a massive opportunity to connect houses. It creates stickiness for the operator and is an adjacent revenue source. And you can do this with millimeter wave with a gigabit to the second to the house, or in mid-band with hundreds of megabits per second. We're seeing quite a bit of traction now in the US and around the world around 5G fixed wireless. So that's a great adjacent business. But really the intent of 5G was to move into the enterprise and these new enterprise use cases. So whether it was the venue like the SoFi Stadium or a factory or an enterprise, that's the next step. So we're bringing the coverage indoor, improving that coverage to enable those use cases. And then finally, these innovation use cases and taking them from the lab to commercial to mass market. So for example, drone delivery, taking that mass market, autonomous vehicles, or cloud gaming is a good consumer use case as well. So this is really the 6 steps that are happening in the industry right now. But just to make this a bit more concrete, I wanted to take some examples of something really happening today. And so I borrowed from, this is the Ericsson 5G Smart Factory at Lewisville, Texas. And the yellow stars on this chart here show use cases that we're doing today. And so this is a 5G factory where we use 5G to build 5G radios. So the first step is components come in, delivered by truck, they're put onto automated guided vehicles, AGVs, they're moved to the production line, and then the production happens, and then there's an inspection process using AR and VR to make sure the radios are made correctly. One of the key things as well is to check that your inventory levels. And so we have a drone application that moves around the inventory areas, the storage areas, checks the barcode to make sure you have the right inventory. My favorite part of the use case is the digital twin. And the digital twin is having a mimic, a software or a virtual mimic of the actual factory. And so that provides a kind of a time machine, if you think about it. You can wind back to if you had production events and you can figure out what happened, what you could do better next time. And you can move forward in time and do predictions of what happens if I add more production capability to the factory. How will that look? All of these, of course, are underpinned by AI and ML really happening. Right, and so I think this is a great example of a factory use case. And there's about 300,000 factories in the US. Many of those have cellular wireless use cases already, but we're going to see that really proliferate. And there's a real good set of proof points around working in a vertical market of manufacturing and proving out 5G capability. But as we move through 5G, one of the big things we need to do is look after the environment and to be, as an industry, a sustainable industry. So the UN declared a code red for climate last year, and that's something we need to take very seriously. If you look at the evidence here, 19 of the last 20 years were the hottest on record. 2021 wildfires generated huge amounts of CO2, and humans implement 68% of extreme weather conditions. So this is kind of really dire situation that we're in. If you look at the cellular industry, we use about 1.4% of global energy in the actual networks themselves. One of the key things we need to do is break this energy curve. So double the data doesn't mean double the energy. And so how do we do that? We do that by making sure we have the right radio capabilities. 70% of that energy is consumed in the RAN. And so we need to make sure we have the latest radios with the most efficient power amplifiers. We need to make sure we're using software to turn off those radios when you're not using them. So as you walk out of a room, you switch off the light. As you don't need 5G capacity in a particular area, you switch off that radio. But I think on the positive side, these networks have a big enablement factor. And a recent study showed that 15% of energy saving in the ICT can happen from these enablers. Take the example of smart grid. We can use these networks to enable more efficient power generation. Another one would be smart agriculture. We can use these networks to enable better agriculture and more efficient food production, helping the environment. So it's redressing the balance. So I'd say this, as an industry, is a key priority for 5G. But let's now look at the timeline for 5G. And the 3GPP release cycle is the metronome that kind of sets that for the industry. And so if we look at our 5G experiences, so 5G was defined in release 15 and 16. We're now moving into release 17. So this year we complete release 17. So you see that's happening in 2022. It's more or less done already. And then we move into something called 5G Advanced, and that's release 18, 19, 20. And that focuses on taking the foundational layers of 5G and adding in more capabilities on massive MIMO, more capabilities on energy consumption and production, and a framework for AI ML in helping the networks be more advanced. So there's a lot of activity happening in those 5G advanced standardization right now. And then as we look out in the distance there in release 21, that becomes, let's call it a 6G basic release. And that takes you out to 2027, 2028. And so this is sort of the timeline defined by 3GPP in terms of the standardization. And then obviously you have to standardize and then you deploy these capabilities. So there's a lot happening in many different dimensions in terms of standardization. So what forces are shaping the future? And never before have societal forces had such an impact on technology. We are responding with technology to solve some of the social challenges that we have in the world today. On the technology side, we're really seeing that artificial intelligence and machine learning is really proving to be useful now. And of course, that's a buzzword. You throw AI, ML at everything, but now we're at the point where it's really helping. It's really making a material difference. We're also creating a mirror world. So think of this as the digital twin. And ultimately, it's a digital twin of the entire planet. So it's a very powerful capability that we have in this mirror world. There's also an expectation for connectivity in everything, limitless connectivity. Wherever I am on the planet, whatever data rate I need, I expect to be served. That's a big aspiration. And then devices go way beyond the humble smartphone today into wearables and XR, extended reality capabilities. That's something that's really going to happen. And this technology is to respond to some of the society challenges that we have. So climate crisis, we talked about. The pandemic taught us that networks have to be very flexible. We just move everyone to start working from home and all the kids from schools to home. You have to better deal with that in the network. There's a lot of expectation on the networks these days. Redefining trust. It is super important that you can trust the network. It's reliable. You're working in that network. You're doing business in that network. It has to be reliable and it has to be highly secure. Socioeconomic shift. So really that's something like the digital divide. So we need to make sure that we do our bit to close that digital divide to make sure everyone has equal access to network capabilities. And global fragmentation, global scale has been one of the key strengths of the telecom industry. We really need to make sure that we maintain that and not have fragmentation in the standards base. So what's the kind of recipe for that evolution? So a kind of convenient acronym for that is ROSI, which is resilient, open, sustainable, and intelligent. So resilient, we need to make sure that we have reliable and secure networks. We talked about that before, that enable innovation. Openness is a lot. We'll hear, I think, a lot about openness in the next couple of days. So 3GPP has been done actually over many years, a terrific job of making sure these interfaces are open. We are extending that with work in O-RAN Alliance and taking more of the interfaces to be open and using that as a vehicle also for automation. Sustainability, we talked about the imperative for sustainability, but that's something that is really important when we look at any network. And subscribers will start to be able to see and make choices based on how sustainable the network that they're using are. And then the last one is intelligence. So the networks are so complex today, multiple generations, many frequency bands. We need to load balance between them. We need to make parameter choices on the fly. That can't be done by human operators. It has to be automated. And the service management orchestration platforms and our apps and some of the capabilities like that will help us be more intelligent in our networks. So overall, we want this ROSI philosophy of the network. So just to conclude, in terms of how important this all is, so why do we care as a society? We're really building the infrastructure. And I really like this 1935 picture, which is on the left here, which is called Lunch Atop a Skyscraper. And these were construction workers building the Rockefeller Center in New York. And they were building the infrastructure of the 1930s to enable commerce in the US. And it was a really fundamental thing that they did. But people don't realize, and I think the equivalent of the roads and bridges and building as an infrastructure today is this digital infrastructure. And so we need to really make sure as an industry that we keep an eye on the prize to make sure that we're rolling out this infrastructure, 5G and subsequently 6G, to make sure that infrastructure is there for innovation, for creation, and for new economic prosperity in each of the countries. So that it's critical for us to do that, and it's a big responsibility for us to be able to, as an industry, roll that out in the best way to create the ultimate platform for innovation. Thanks very much, and back to you, Alejandro.
Brilliant. Thank you, as always, Paul, for your input and your expertise on just about anything RAN, and in this occasion, 5G. Well, we're going to head on right over to our live panel. As mentioned before, it's hosted by our good friend Chris Pearson over at 5G Americas, and he's joined by speakers from Ericsson, BT, and Robin. So, Chris and team, over to you.
All right, thank you very much. Good morning and happy Monday to everybody. I hope everyone's having a great spring session and springtime. And I am fortunate to be on this panel today, hosting it, moderating it, and hopefully getting to your questions. As many of you know, I'm president of 5G Americas, and we work in three main areas, which are the technical coordination and facilitation, industry outreach on education, and then regulatory policy. And so if you want more information, just go to our website. But again, I'm very fortunate to have a panel to really kind of dive in a little bit deeper to some of the key topics that Paul just mentioned in his great keynote address. I'm fortunate to have three panelists, and I'll just introduce them and maybe they could nod or wave. I am fortunate to have Neil McRae, who is the Managing Director and Chief Architect of BT. Welcome, Neil. Also, I'm very fortunate to have Mehran Hadipour, a VP of Business Development and Alliances for Robin. Welcome.
Hello.
Welcome, Mehran. And obviously, we just heard from Paul. So welcome, Paul, to our panel to answer the questions. So what I would like to encourage the audience is if you have questions that you would like this great panel to answer, just make sure you use your Q&A tab on your webinar platform and provide those questions, and we'll try to get to them. We do have some questions that are kind of burning questions for the industry that we will get to today. And so I just want to start out with just a general question. And this will be for anyone or everyone on the panel. So what are the biggest areas of kind of existing, kind of existing and can be in the commercial networks now, as well as upcoming commercialization very soon? What are the biggest areas of innovation that we see in 5G RAN? So kind of like where we are with 5G RAN commercialization, and maybe where we're getting pretty soon, not 10 years down the road, but just where we are now, but also where we might be in a few years. So maybe we'll start. Neil, do you have any thoughts on that?
Yeah, sure, and thanks for having me on the panel. Where we see real kind of innovation happening right now is kind of two spaces. One is in private networks, 5G private networks, where we are seeing us build out bespoke networks to cover, challenging use cases where the public network either doesn't go far enough or may not have all the right feature functionality in terms of authentication or device support, etc. And that's more than just the RAN, though. That also includes core.
Right.
I think the other area where we start to see really some great innovation, and we're trialing this right now here in the UK and Hull, is all around the RIC, the RAN Intelligent Controller. We're seeing some really impressive early results on what you can do, and reflecting back on the presentation, particularly in things like powering down and optimizing the network for the use case that you need it to run. So, you don't need 5 carriers of spectrum beaming out of the network at 3 o'clock in the morning, but you do need that at 9 o'clock in the morning. So we're seeing some really exciting ideas come out of that. Some from partners, some that we're actually kind of writing the code ourselves around what we call ultra MIMO and getting the most out of the radio. So that's where we see some really great and really great innovation, and very much focused on the customer, which is not always the case when we're talking about
Right.
radio.
Right. Yeah, that's good. And I know it's a broad question, so I want to give both Mehran and Paul a chance to answer it. Mehran, where do you see some of the innovation that we could see today in commercialization and maybe a few years down the road? And then I'll go to Paul.
Sure. I think this whole in this whole space is getting a lot of attention in terms of this whole softwarization and containerization of the network stack. Being able to build a much more efficient network function delivery platform that can support a variety of open standards and different providers for different components of the network, heterogeneous and open architectures. And coupled to that would be this infrastructure management scenarios that you have to be able to kind of deliver that in production. So I see a lot of momentum. There's a lot of new providers in the space. I'll see, many new network function providers building containerized network functions for 5G service delivery almost daily. So I see that a lot of innovation kind of taking over the market in this space.
All right. Paul, how about you? Where do you see the innovation, kind of like commercialization innovation today, and then maybe in a few years?
So as a radio person, I'd pick a radio topic, which is massive MIMO. And so it is massive MIMO is something that's sort of the muscle behind 5G, or the really the workhorse behind delivering capacity. And so we've had that for quite some time in the technology, but it's really moving pretty fast in terms of the capabilities. So we're on 3rd and 4th generation radios. We have software capabilities that are advancing every day as we learn from the field environment. So massive MIMO in downtown Manhattan versus suburban Dallas, they're different environments. So we're learning to tune the network, we're learning to make these radios much more sophisticated, because ultimately spectrum's expensive. You've got to get as many bits per second per hertz as you can out of that spectrum. So the effectiveness of massive MIMO is really important. And also going to wider bands and dual band kind of massive MIMO, I think that's one of them. And then I'd pick as another one something that we're working on now, which is time critical networking. And so we talked about the latency advantages of 5G. We talked about that a lot, but now we want to really manage the latency. And so one is, I want to reduce my absolute latency. So 10 milliseconds is better than 40 milliseconds. But it turns out that a lot of applications are sensitive to the variation in that latency. So gaming particularly. So a gamer would say, oh, this is a laggy game connection because of the distribution of latency and so having a nice tight distribution will help. So techniques in software that can help make sure that latency is better managed will open up these new applications. So cloud gaming especially, I think there's a lot of opportunity there for time critical networking helping it. Also factory and production environments that are very sensitive to that need that time critical. So massive MIMO and time critical would be my two slightly technical answers there.
Yeah, that's great. Well, one of the things that a few of you mentioned in your answer is that idea of optimization. And obviously there's optimization of the RAN, and then there's also optimization of the core network. But maybe I'll bring it back to the panel as well. How do we see managing this optimization when it's your radio access network, and you're looking at different use cases, you're looking at different, just what you said, different latency, all kinds of things. And then even Neil, you mentioned enterprise as this big opportunity, and there's different, basically areas that you need to optimize for them. So maybe I'll throw it to the panel. How do you look at the RAN now, as far as how do we optimize it to the various use cases? What are the opportunities there, and what can be done? And maybe Neil, I'll start with you as the operator.
Yeah, I mean, I think it's. I think you're right to focus on this area. We invest big in it, and we've tried to have one size fits all. And I think what we're learning about, I have this word, I call it networkification, It's how we take the network further into our lives, into how it affects humans, but also increasingly how it affects how machines are going to talk to each other. And really the reality is the one size fits all approach that we've done for the last 20, 25 years probably isn't the future. And that's why we need programmable radio, we need flexible radio, we need to move more and more towards a software-based radio. But also we need to figure out the ways where we get much better insight on what the customer is about to do with the network. And that's where I think we've got great weakness right now. So, we may have a customer that's about to, automate something on his production line without really talking to us and without us being able to detect that. And I think right now the radio it does feel like we're kind of broadcasting out, where I would like to see much more fidelity from the network and from the device the customer is using to be able to signal the sort of environment, the network environment that use case or that customer needs. And I think, I see us moving in that direction with the fantastic work we've done in 5G around signaling and data paths. But I think we've got probably quite a lot more way to go. But my goal is to make more and more of our customers more and more dependent upon the network, and we're only going to do that if we really think of the network more as a kind of a laser beam approach to trying to hit the target, as opposed to a kind of a big torch trying to illuminate everything. And that's why we're excited about the RAN intelligent controller and other things that we're seeing on devices to give us better insight as to what the use cases that customers want to use are.
Yeah. Mehran, anything to add on that as far as the optimization of and how we would get around our hands around that for the different use cases and stuff?
I think Neil made a good point about this whole challenge with different use cases having different requirements. I think especially for enterprise 5G use cases, beyond the radio, the rest of the infrastructure to build the low latency connection, for example, for a video analytics application, would have a different infrastructure requirement completely compared to standard operator-based 5G use case for a metropolitan area. Many things around the scale, the number of connections, the low latency requirement has to change. I think the remedy to all this is the idea of softwarization of the entire stack to be able to optimize the actual network functions to the use case they're trying to deliver. You also have to have a level of automation built into this, because many times, especially in the industrial use cases, the operators are not involved, right? The enterprises really need more of a turnkey model to be able to deploy these backend infrastructure to do, for example, a quality control system or a smart city application. The whole approach to service delivery would be different, right? If you add some of the complexities of like neutral host and being able to have a shared infrastructure and so on, automation even becomes a more bigger play. But I think we are on the right path, thinking that we are now getting closer to a disaggregated infrastructure, but you have to add the automation that you have to be able to combine these network functions from different providers for different use cases without having to reinvent the wheel.
Right. Paul, your thoughts on this? How do we? I mean, you mentioned it a little bit in your initial, because you talked about the gamers and the different latency issues there, and then you got to manage this network. You got the RAN that we're here. We're talking about the RAN, but it's this kind of the entire infrastructure ecosystem and how you manage that and optimize it. What are your thoughts about the challenges and how we do that?
Yeah, I mean, we've come a long way from sending out a drive test team, getting some feedback, and down tilting an antenna with a GSM on single frequency, right? I mean, that was I grew up with those kind of things. That's sort of so old school these days. It's unbelievable. So now we don't want a drive test team. We need feedback from the network itself. We have crowdsourced data. We don't have the best closed loop system for that, but that's something that we need to work on as an industry. It has to be automated. I think Neil and Mehran talked about the automation, the Open RAN platforms, the RApps provide good way of doing some of these closed loop systems that will help for that. But also it's redefining some of these KPIs. I mean, it used to be what's your drop call rate. That's not the case anymore, right? Now it's it's what for each of the applications I have. If I'm flying a drone or an autonomous vehicle, or I'm in a factory, or I'm in SoFi Stadium for the Super Bowl. Each of those, they have a different set of KPIs that need to be managed. Now, of course, then just to make it even more complicated, we're going to do that on a slice by slice basis, right? So an enterprise has this particular SLA. I'm delivering that to that factory for that use case. I have an SLA for fixed wireless, maybe, and I have an SLA for mobile broadband. So we've got to wrap all that up on a per slice management. So this complexity just reinforces the need for that automation. And of course, you throw some, we have the obligatory AI/ML in there to help manage this. But if you're trading off all these different bands, you have to load balance between these bands. You've got to use every bit of the spectrum that you have and deliver the right SLA to the right customer to make maximize the profitability for that customer. So this is a super complex problem. Automation is the key. Platforms for automation is the way to go. It's an exciting area, though.
Yeah, great. Well, those are great answers, and I think that you guys really did explain the challenge and what we need to be doing to overcome that challenge. Well, there is kind of the elephant in the room a little bit here, but about the idea of the network, simplifying it, even though it seems to be getting more complex. A lot of different areas are being developed and innovated, and so let me just throw a few ideas about and see what your thoughts are. I mean, right now we're in a very interesting time with network, cloud native networks, Open RAN, open source, all these different elements that are coming into play that are making really our ecosystem much bigger than it used to be. What are the panelists' thoughts about open source, Open RAN, and kind of the cloudification of everything in the network? Maybe Paul, go with you, and then after that we'll go to Mehran, and then Neil, as an operator, you can bring us home on it.
So Open RAN, I mean, that gives us, we have to sort of break that down into a few pillars, I think. So first of all, Cloud RAN virtualization is one topic. Then we have automation, which is a whole nother topic with service management orchestration and RApps and things like that. And then we have other open interfaces. But maybe I'll pick on Cloud RAN. I mean, I think that networks of the future are going to be built with a virtualized RAN. And so and we call that Cloud RAN. So that's something that's going to happen. I would remind everyone that it took about 10 years to virtualize the core, right? So it's not an overnight thing, but it's certainly something that we see is going to happen in our customer networks. And so in order to do that, we need to make sure that we have the right platforms. We have cloud native software, as you mentioned, that we have the right set of servers and the right cloud infrastructure. And we need to make sure that we help our operators, we help the community get to this cloud infrastructure. There's a lot of retraining needed to make sure to get upskilled so we can build these cloud platforms. And then we need to make sure that the performance is right. And so building a virtualized RAN in central Manhattan versus in a rural Connecticut, for example, are different things. And so we need to make sure Cloud RAN is there with the right performance and capabilities. But I think that's certainly going to be a key tool in the future for networks.
Great. Want to go to Neil? No, let me go to Mehran. Let me get your thoughts. I mean, I threw out quite a few because I wanted the panelists to choose what they feel like they want to answer on this one. But what are your thoughts on some of the areas that I mentioned?
Good point. I agree with Paul on this. I think the challenge, we are looking at this whole Open RAN and virtualized RAN with a lot of promise. There's people who really gotten to a point that they're building end-to-end virtualized stack on containers are seeing significant savings for diversification and softwareization of their stack. And that is going to drive a lot of momentum in the innovation going forward. As Paul mentioned, the challenge that has to be solved, this whole idea of automation that supports this kind of disaggregation. Think about the issue like in the nowadays, we're going to deploy these small x86 platforms in G-Node-Bs and in remote locations. And if you have to do anything manual to any of these devices, and these are all servers, right? They have to be upgraded. The BIOS have to change. There will be security changes that has to happen. Anything manually done at this scale of 5G would be make 5G completely unaffordable. So you need to have systems that do what I call metal to service orchestration, meaning from the point in time a box is placed in the base station with nothing on it, to all towards its life cycle with upgrade automation, installation, and deployment of network functions on top of them should be end-to-end automated. When we get to that point, then you have a situation that now you can remote manage the entire infrastructure and fine tune it for a specific use case and manage its life cycle in a much more affordable way. And I think that would be when this whole open RAN, containerized RAN will really take off.
Okay. Yeah. Good. And Neil, you're one that has to put it all together in your network. A lot of different options that are coming your way now. So, what are your thoughts on some of these kind of big buzzword topics?
Yeah, I mean, look, I've been writing. I've launched the first ISP here in the UK in 1992 that was only running on open source. We're running it on NetBSD, Linux, GateD. I've been an open source contributor for pretty much most of my adult life. In fact, some years before that. The thought of being able to just get a hold of the code and change it and adjust it and fix it, I can understand why people are excited about that. But go into a telecommunications company's NOC and show them an excerpt from a C++ piece of code and ask them what it does. And the stark reality is they won't be able to answer. And I think that's the thing that we're really missing out, which is how do we operational this new technology, this open source technology, in a way that operators can digest it. And I can't help but thinking back on NFV, where most operators have not seen any benefits out of that. Predominantly, one, because I think it was positioned as a kind of cost saving more as a revenue generator. And two, because of the skills and complexity that it created, and certainly we built our own network cloud platform, our own stack, and it's tough. So when I then want to overlay the 5G core and cloudify my RAN, I kind of look at it and think, are we actually going to be able to run this and operate this platform? So one of the things I'm very happy to see in Open RAN is some what I call the various distributions that are coming along, with what Rakuten Symphony have got coming out, with what some of the other vendors, where they're starting to work together to put together an end-to-end solution, because I think that's the only thing that big operators are going to be able to digest, which is something that's pre-integrated and that delivers the feature functionality. I'm really doubtful, having run many RFPs and trials and tests, I'm really doubtful that this technology saves me any significant amounts of money. But I do see it creating value in the way that we can take the network further, as I mentioned, in private networks, and some of the solutions that were in the presentation that Paul gave. So I definitely see that there's some opportunities there, but I am, in some of the spaces that we're almost deaggregating almost to reaggregate, and I kind of wonder if that's really going to deliver what our customers want. It's very unclear to me, and it's very. I'm very nervous that we get overly focused on an architectural concept that most of our customers don't understand and don't really care about. They just need it to work. And that's why I'm very much of the view, which is, how do we signal more from the user of the network to help us understand what we need the network to signal and build and bring together to give our customers the beautiful kind of landing place that their application needs or their use case needs. And there are some things that come out of that in greater telemetry, greater analytics, using AI to predict things. Again, I think we're at the very starting point of AI, and if you just think about the network over the last 30 years, it takes time for these innovations to feed through and for us to go through the hype curve of, well, what can this do? And we've seen it with 5G. 5G is going to save the world, and now we're kind of refocusing it and re-engineering it into things that we know that it can make a difference on. So I think it's great to say, let's create communications technology that will save the world. I think that's a brilliant thing to do, to give us a direction. But then we've got to figure out, okay, how do we land it, and how do we make sure that all the promises that we make in the network get delivered to our customers, and our customers feel the difference. And really, 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 really important, want to pay us to keep building the network that we need to invest in year after year after year. Because I get a sense that many of our customers are thinking 5G is just like 4G, and why am I paying as much as I'm paying, and why is the price going up, and why is it more expensive? I think that's something we've got to face into over the next few years. Otherwise, I think we find ourselves in a really challenging situation, trying to generate the investment that we need to keep our networks at the forefront of the technology demands of the planet, frankly.
Yeah, actually, if you think about it, it's amazing what our industry has done. All of your companies, as far as researching, developing, and improving the networks over time. I mean, any other industry in the world would be in awe of it. And yet, as you say, we have to think about, well, how do we continue to reap some of those benefits so that we can continue to invest in the research, development, deployment of these great networks that we have. Neil, you mentioned something.
Sorry, I just want to build on that. I'd be careful about that. I'd be careful about that. I think in many cases we have improved the network. I think there's some places where we've still got a lot of work to do. Indoor coverage is still very challenging. Rural coverage is still very challenging. I think you're right. Definitely made the network better. But I think we've got, as I mentioned earlier on, I want the network to be in every single place, so that every device or everything that our customers are doing has a network component of it. And that really requires us to think very differently about network.
Yeah. Well, something Neil mentioned, and I'm going to ask Paul your thoughts on it, is Neil mentioned artificial intelligence to help, really the wireless infrastructure. I'll put these words in there. Artificial intelligence to help the to help the infrastructure management and so forth. He even talked about the customers, knowing more from the customers on a real-time basis, or so forth. What's the role of? I guess ask all the panelists. What's the role of the growing role of artificial intelligence, perhaps, in infrastructure, whether it's managing the network or other areas? What would your thoughts be on that?
Yeah, I would say it's trying to simplify the network in network operations. And so, as I mentioned before, if you think about the combinations and permutations that you have today, where with different bands and technologies and different cell sites and architectures, how do we make that easier to run? That typically, you're optimizing thousands of parameters, and that's just not possible on a human basis. So bringing in AI ML to do that is something that we're working on. And so today, there's applications that are running that are managing load balancing between different carriers or different bands, right? You can do that today. You can use AI ML to anticipate when you should switch off a radio to save power. These things happening today. So they're more bounded problems. And then in terms of the service management orchestration platforms and our apps then provide a platform and an infrastructure to be able to apply more AI ML technology or capabilities to those networks. And so then you can bring this into the user domain to say, okay, I want to anticipate and predict the user performance and modify that user performance to make that user happier. And so back to Neil's point, it's like all this stuff internally to a network is like the user does not care. But if I can make it so that person does care and notices the difference. So for example, if I'm a first responder and I'm heading to an emergency scene, if the network can anticipate that I'm heading to some sort of disaster situation and allocate me more capacity before I get there, that's very useful. So moving these into the user domain so that the users see end impact, I think that creates a lot of value and justifies them being on a particular network or not. So I think that's what I would say to that.
Yeah. How about Mehran? What's your thoughts on artificial intelligence having a growing role in the infrastructure?
Thanks for the question. I think I see several roles for AI that I think is already in some ways being proven. For example, a OBF and reaction to observability requests for scaling and healing automation, for example, is one. We actually have a project with Intel that we showed in NWC that we would take the AI data and change the frequency of the GNOV nodes when they're not needed and bring it up or down depending on performance requirement. That saves 40% of power. So this could be something that has to be done on an entire network level. It has to be AI-based, has to be automated, and so on. So the other piece is how to actually maintain better availability of the network infrastructure by having AI models that take a look at the entire stack and have permitted endpoint feeding to them and can understand exactly what's going on in an active way and take action accordingly, extend the OSS-like platform to much better functionality going forward. So I think that's another place I see immediate impact for AI. I wanted to address something that Neil was saying. He expressed some concerns about he doesn't exactly know where the benefits are coming from for all this modernization and so on. Having been the cloud platform for Rakuten Symphony for deployment end-to-end 5G stack, we've proven a number of savings on instantiation time, 80% reduction, being able to quickly deploy a new infrastructure, both CapEx and OpEx reduction of a significant nature. And I see operators will look at this and understand the benefits, and that is what is going to drive the momentum in deploying 5G. So we feel that the saving is there. We think this containerization and segregation is important. One of the things I like to say, though, however, that not everything, as Paul mentioned, is containerized, right? Many network functions are not containerized today. So you have to have a platform that can do VNFs and CNFs in a common network infrastructure and be able to deploy and manage it. And once you have that, then you don't have to wait for everything to be containerized, and you can deploy a much more flexible containerized infrastructure. And some of the problems that, for example, George mentioned, what are the infrastructure challenges in his questions? If you look at the end-to-end orchestration of all the network components from bare metal to a point the service is deployed, everything has to be automated, and Kubernetes goes a long way in doing that. Sorry, I'm losing my voice.
No, that's all right. All right. Neil, did you want to add anything as far as the role of artificial intelligence in RAN or the overall network?
Yeah, I mean, look, we've had RFPs out, and the savings compared to what we pay now, they're not there. I mean, it's really simple. There's a number, and they're not there. Look, if you're running a network that doesn't have half the functionality I have in my network in the UK today, I would expect it to be low cost. Today, we have BT Network Cloud. It's a phenomenal Kubernetes containerized and NFV platform. We can spin stuff up, we can spin it down. We've been doing it for years. Our entire TV platform has been running in that mode. It's not a new cost saving, it's the new normal. And I think that's what, in my mind, that's what people need to kind of really start to think about is where is your baseline and where do you go from there? In terms of AI, actually, the case that Paul talked about, we've actually implemented that using AI, and BT has more AI patents than most companies in the world, where it's been a very strong focus area for us. And actually working with one of the hospitals in Birmingham, we deployed what we call a connected ambulance. And that's a blue light service, and we run the emergency services network for blue light services in the UK, where the ambulance is signaling to the network, I've got a patient, I'm scanning this patient, I need guaranteed bandwidth delivery, I need low latency, so that by the time I arrive at the hospital, the doctor, the diagnostician has already seen a lot about this patient. This is a real live use case that we're using AI, the RAN Intelligent Controller, to deliver today. And it saves lives, and it's a phenomenal 5G use case that we want to build on. And in a world where healthcare is becoming more and more important post-pandemic, and the after effects of the pandemic, everything that we can do to reduce the health, to improve the efficiency in hospitals and healthcare in general is welcome. In fact, I've seen an embracing of using this technology in the last few years more than ever. So, absolutely AI has got a big part to play. But again, I just want to remind everybody we're kind of at the very first egg hatching part of AI. We've got to let it develop. We've got to let it mature. We've got to make the mistakes and rethink and retest and re-engineer. But because I think AI is a very and machine learning more so. It can kind of be a bit of an animal if you're not careful about how you're deploying it. And again, we've got some phenomenal AI experts, leading AI experts in the country, and in fact in Europe at BT Labs, that have been working on this technology, and actually during the pandemic allowed us to re-engineer traffic as people started to work more from home. So AI and automation, and actually the guys at Robin.io have really done some phenomenal stuff in automation. That is absolutely the future. The network is too complex for humans to run. I've been saying that probably since 2014. And we've got to do more to automate, and we've got to do more, and not just to save money. Yeah, we might save a few quid, but actually to be able to stand up those new services instantly and be able to drive the uses as the customer signals us. So I've got an ambulance signaling me saying, hey, I've got an emergency. What are those other use cases that we could get to signal us that we can, charge more or provide a different level of service so that we're actually generating demand for the network, as opposed to kind of just being used as a cheap way of delivering video.
Okay, great. Yeah, no, good answer. What I want to do is make sure I get to some of these audience questions. So I'll probably just direct this to one person or another, as we're down to about 8 minutes left, I believe. So a question is this would probably go to Paul, since you mentioned it in your keynote presentation earlier. Does 5G consume more power compared to earlier technologies? And what role does 5G play in achieving the global carbon emission reduction? So maybe you mentioned it in your presentation. So question for you.
Absolutely. So 5G gives a 40% energy per bit benefit over 4G. So that means if we moved every 4G subscriber to 5G, we'd save 40% of the energy. So that's important, right? And so that's the coding and the modulations and the way that the 5G architecture is set up allows that. So it's fundamentally energy per bit. Now, of course, as we go forward in the world, we're going to have more and more data. So 26% CAGR data growth in the next 6 years, we have to deal with that. And so that's what this concept of breaking the curve. When I double the data that I'm using, I don't want to double the energy. So I have to keep working on more efficient power amplifiers and better software to turn radios off. All these things is really important to do that. And so part of the energy consumption is 1.4% of global energy is consumed in RAN, in telecom networks, and 70% of that in the RAN. But this benefit of when you do digitalized services, you can get savings in the ICT industry, and there's this enablement opportunity to say 15% of ICT energy can be saved because you're not doing a truck roll, or you're generating energy or doing agriculture in a smarter way. So we have to think about that, and that's the offset and the balance. And then we need to make sure that all operators have and vendors and the whole end-to-end ecosystem have those carbon neutrality targets and stick to them.
Okay, great. Maybe I'll see if Mayron wants to ask this. Mayron, what do you? The question came in. What do you think about the partnerships between mobile carriers and cloud providers?
Oh, that's a great question. Well, I think almost everyone, including all the cloud providers, are trying to take advantage of this business opportunity of 5G, and they're trying to figure out where their play would be on the cloud. I do see cloud has a play. I think within orchestration, automation, and core, there is a definite room for cloud. And the far edge, since you have to be very local and close to where the data is being produced, cloud would have a lesser play, but all those guys, including Microsoft and the rest, are building platforms for edge deployment, and I see some of those will take some hold where appropriate. The question there is going to be cost point. Obviously, both the enterprise use cases and also at the far edge, the cost is a key factor because of the quantity of the deployment. So it's going to be a battle for that. But I think cloud providers being the source of automation and running some of the network functions like OSS, BSS, and core would persist. Also at the edge, some of the MEC and some of the other applications will see a good use case in some of the cloud. I think hybrid cloud would definitely be a model that more and more deployment would come through.
Okay, great. Maybe I'll send this to Neil. What are your thoughts about fixed wire access and the spectrum that would be used for it? Can millimeter wave be used when it's difficult to penetrate walls, or will fixed wireless access be a combination of various spectrum? So I guess it's a little bit about millimeter wave and fixed wireless, but it's also about what other spectrum might be used.
Yeah, I mean, I probably need an hour to answer that question properly. But look, let me give you the kind of the 2-second answer. Look, I think all of these technologies have a place to play to help us connect more and more people and more things. What we have to do is figure out where we use them and when we use them. Millimeter wave, trying to use that to deliver home FWA, and if you're in a world where you've got lots of MDUs, apartment blocks, there's definitely a use case for millimeter wave if you build it right. Here in the UK, we have this saying, an Englishman and his castle, and we don't have many MDUs. We have lots of houses that require the build you would require to get FWA to work. Actually, when we did the numbers, it worked out cheaper for us to build fiber, and we're out there building fiber to 25 million homes, almost every home in the UK over the next 5 years, because we felt that was the best solution. Now, it's great if you've got 1 gig or 10 gig or maybe even 40 gig to your home. Then the discussion becomes, okay, how do I use radio and these technologies inside the home? How do we use, imagine we start to use millimeter wave inside the home so that big pipe that home users have got or businesses have got can actually be used at its greatest potential. And I think the wirelessness, if you like, of the home or the office or the venue is going to be one of our really big interest and challenges over the next few years. And it goes back to my earlier point about, networkification of these places where, we've kind of hit the edge of the building and said, okay, it's too hard. I think that a big chunk of the future of our businesses is going to be about going into buildings, going into locations, and FWA will play a part of that. And actually we're the USO carrier here in the UK. We use FWA to connect to some locations because it makes sense. But as a long-term strategy on its own, it's hard to see how you make that work. Using it in certain use cases, absolutely, it works really well. And again, we're partnering with a phenomenal company called Tarana to build fixed wireless access in places where it's hard to build. And that isn't just in rural locations, by the way. There's many urban locations where, because of permits or other challenges around the history of the location, where FWA can connect things that, digging the road up and building fiber might not be the best answer or might be a difficult answer. So it absolutely has a place to play.
Okay, great. Well, I have more questions, and I know you have more answers, but we have run out of time. I really wanted to get to a metaverse question, but I guess that will be our next panel on Fierce, maybe with the 4 of us in a future date. But I do want to thank, on behalf of Fierce Wireless and 5G Americas, I want to thank Neil McRae, Mehran Hadapor, and Paul Chaloner for your time today and helping everyone start out their Mondays with the 5G Blitz at Fierce Wireless. And with that, I'm Chris Pearson, president of 5G Americas, and I am going to turn it back to Alejandro for the next presentation. But again, thank you so much and have a great week, all of my panelists.
Thanks.
Great. Thank you so much, Chris, and of course to our panelists for that great discussion and to all the questions coming into the Q&A. Thank you to all of you participating. As always, it makes the discussion much more interesting and relevant, of course, to you attending today. We're going to head on over to our closing keynote for the session. We're joined by Same Yamani. He's the CTO at Viavi Solutions. Same, the stage is all yours.
Thank you, Alejandro, and thank you for giving me this time to present. Again, my name is Same Yamani. I'm Chief Technology Officer of Viavi Solutions. I'm going to talk a little bit today about the 5G RAN and where we're seeing the maturity in the 5G RAN and where is the state of the market today. To start, maybe a little bit of a history about Viavi. I mean, Viavi in general, we are one of the very well-established test and measurements, optimization, and monetization and monitoring company out there. And specifically on the wireless domain, we had a long history of helping both the equipment vendor and operators going into the new technology of wireless and all the different generations. 85% of worldwide 5G node base today uses Viavi tools for verification and installation and support. We have a very strong position in testing in the lab with the vendors and doing also field installation and verification. And we have a heritage of being ahead of the market in terms of providing solutions. Like in 2014, one of the first NFV, that's completely virtualized test solution. We have been leading the world with a lot of the players in the ecosystems for O-RAN. So I'm going to touch a lot of different parts of this in my presentation. I just wanted to give a history of what Viavi is. But in reality, if we look at where the market is going and where the industry is going, I mean, we are moving away from traditionally building these static, physically, purposely built kind of networks that you stitch together to provide a certain application or a certain technology into this completely automated, virtualized, zero-touch services. And the idea is to be able to enable new kind of verticals to use the network and use the services the network is providing. And this will be faster to deploy, faster to provide the capabilities, and use a lot of the analytics and the machine learning to actually build more capabilities on top of that, and then monetize the same infrastructure to be able to support different requirements. And this is really, if you look at how this cloudification and softwareization of the network is moving, and we have seen a lot of examples of the core network already being cloudified and moving into this direction. A lot of operators today and a lot of the market today talk about edge computing to provide very low latency requirements of applications, like we're going to talk about cloud gaming and some of these capabilities. And then the access technology has been evolving as well, not only moving in terms of software, but the openness. So the idea of Open RAN and RAN intelligent controller is now coming into the picture and maturing. And the idea at the end, all of this is to be able to provide these new verticals, this IoT verticals, IoT industry, not just for consumers and for providing better services at the handset, but also enabling new verticals like automotive industry, industrial automation, smart ports, smart cities. All of these new kind of applications will benefit from an open network that can be configured and being expanded based on the requirements from the network. So again, looking at all of these different segments of the network and how they can be orchestrated and provide the capabilities that meets an automotive industry or manufacturing or healthcare or retail, means that also the way you test it, the way you optimize it, has to also follow the same concept of building a slice in the network. And this is where we're going to really spend sometimes talking about here. So for example, when you talk about factory automation using this new cloudified network, we talk about a location where you may have a lot of sensors. In some of these applications, there is like 1 million sensor and IoT devices communicating within each other on the manufacturing floor, and being connected by an AI automation system that helping and doing a lot of decision making. That requires a certain characteristic of the network. On the edge side, you need artificial intelligence kind of resources. You need to be private because these will be within the manufacturer platform. You need ultra low latency capabilities, densification. I said million kind of sensors, and some of them will be mobile. So this is one requirement you're going to see in one of these segments. Now, if you move to a different segment like healthcare, which now with the pandemic, we're seeing a lot of requirements for remote consultation, for remote surgery, telemetry, training remotely with AR and VR. Again, ultra low latency is important. High bandwidth becomes also important on both the edge computing and the access technology. Another example here is smart ports. When the chip come into the smart port, complete digital manifest, and every part of the port and the containers, there are sensors there. You need to be able to manage and find out what changes are. And so again, another example where it's a private network, requires a big scale because of the number of sensors, so densification, and then AI intelligence. So you can see a lot of different requirements, and you have to be able to build a slice within the network, within this cloudified network, and at the same time, each one of these slices will have their own SLA, their own capabilities. So the testing, the assurance, the monetization, the verification has to be also instantiated as part of this slice. And this is exactly what Viavi is doing. The swivel up chair approach here is not going to work, just verifying the access and then verifying the edge and then verifying the core. You actually have to have orchestration across not only the different components of the slice, but also the different system that is managing it, monetizing it, and as well optimizing it. And if we focus a little bit on also 5G and how the 5G architecture is evolving. I mean, in traditional network 4G and before, you had radio access network with radio resources, and you have different solutions to manage these resources, optimizing it, and understanding the different behavior in terms of coverage. And then you have the mobile core, where a lot of these sessions and control plane and user plane are being done, and many of the intelligence within decision and services there. And then you have the data centers, kind of middle of the road with some of the LTE Advanced and LTE Pro. We have seen the virtualization of some parts of these networks. So we see like these BBU hotels and the centralized RAN. We saw also the virtual EPC. So this kind of like moving towards kind of virtualizing and software-based network. But 5G took this into a different layer, with opening up the interfaces with ORU, ODU, and OCU, adding mobile edge computing there, and really the delineation between where the intelligence resides are now depending on the application. You will see intelligence coming closer and closer to the edge. You'll see you need to have more management of user plane at the edge. So this is really creating kind of removing the delineation between what was RAN and core, and you really need to look at the entire slice as one construct, RAN to core, having intelligence moving to the edge and having optimization at every part of this slice. The other development that we are seeing out there is the Open RAN. So, traditionally RAN has been a closed proprietary systems where, every time you need to add new features, you have to work with the vendors, and you have to, have a steep coming out in terms of time to market, with not too many open interfaces and no interoperability between the components. So this we have to move with Open RAN into more of a disaggregated, moving away from proprietary systems, dividing these, RU, DU, and CU. Still, this was the first implementation of a disaggregated RAN with a cloudified core. And then eventually the Open RAN is going to be completely cloudified RAN, open APIs with interoperability between multi-vendor, with RAN intelligent controller running both, at the software component, at the access, and of course, the edge itself becoming a cloud-based solution. So this is really the transformation of what used to be a traditional RAN to the Open RAN concept. Now, this will enable a lot of capabilities of providing, cloud edge and more ultra low latency capabilities. But again, this also requires that you have to have a very sophisticated testing and extensive testing to verify that this edge is going to meet the requirements. With software edge, you need to understand you're going to be able to perform what a live network condition is going to require from this cloud edge. And you cannot assume that what you have already in a public or a private cloud can work the same in the hybrid cloud. So, there is more levels of complexity that you need to do there, and you have to do a lot of different testing and optimization for that. If we look at history, with 4G, total latency between, round trip delay, you talk about 190 milliseconds. With 5G, there is a little bit of more improvement because of we're using new radio and new base station, but we still are within the 180 millisecond. But if we open up and we have mobile edge computing, the idea here now, this is what enables the ultra low latency capabilities, and we'll talk about 12 milliseconds. But these things have to be verified and have to be tested. And I give a good example here. A lot of these motivation for having cloud edge. One of them is cloud gaming, for example. And here is the case: is the operators need to make sure that the gamers are receiving an optimal experience. And in this case, the actual game is running at the edge, at the application servers, and the user plane is being moved, and the intelligence being moved at the edge. And you have to manage, this kind of real-time rendering and providing the gamer with a 4K 60 frame rate, ultra high definition experience without having to download the game. So again, a lot of requirements, a lot of processing. You need to be able to test these kind of capabilities and test the round trip delay. In this case, for example, have a latency of 10 or less than 10 milliseconds, or between 10 and 20 milliseconds. So this is an example how building a specific application or a slice on this kind of network requires very dedicated testing resources and verification that matches what the requirements are. So this is the complexity of open interfaces brings a lot of different requirements. We're trying to make it open, but you actually have to manage some of these complexity behind it. Understanding the end-to-end functional performance and the capacity, the latency requirements, guarantee interoperability. We're gonna open it for multi-vendor, but you have to actually guarantee the performance and not having finger pointing between different vendors on where the issues are. Validating timing synchronization, for example, between ACPRI interfaces and some of the interfaces, guaranteeing performance at scale with all these multi-vendors, and also managing this with the legacy, because even with 5G, you're still going to have to operate with legacy system, legacy radio technologies. So that's the complexity and test challenges in an open RAN environment. And we are seeing a lot of maturity in the market today, moving from where we are into a more mature environment. A lot of these Plugfest and OTIC are now bringing different vendors together, and we're working hand to hand with them in the trenches, trying to validate that the interoperability is working, putting some standard requirements in terms of operating on a certain level, doing all of these testing and seeing how much performance we can get. So we are, the industry is maturing. ORAN, I always say ORAN is here to stay, and we're gonna see much more deployments happening with ORAN as this technology now mature, and as people coming together and testing it together. This is one thing that Viavi does. We have a complete portfolio from the time we are looking at in the lab. So a lot of these vendors, other ORUs or ODUs or OCUs are testing with some of our emulation in the lab, trying to understand the performance, trying to do some of the interoperability tests before going in and providing their product into the market. And then we're working with operators and first field applications to test this in deployments and making sure that deployment with all these complexities are automated. And once it's installed, we have tools for continuous verifications, monitoring, provide field support and troubleshooting, and then eventually optimize, because each time you have a new vertical, you really need to optimize all these different components. So we provide a lot of analytics tools and optimization tools from RAN to transport to core. You cannot just optimize in one segment. You have to be able to optimize across all of them. And if we want to specifically talk about something that is being developed, the RAN intelligent controller, there are three layers when we are looking at RAN intelligent controller. One is the open interface, like the E2 interface, and making sure that RICs can interoperate with other parts of the network. So, setting up the E2, making sure that you have the right, service platform, the right configuration and connection management. And then, on top of that, you start building some RIC scenarios or RAN scenarios. And when we be able to generate some of them theoretically, some of them actually using real data from the network and emulating different solutions and see how the RIC responds back to these kind of scenarios, and eventually provide also a platform for X-app validation. So when you start building apps on top of the RIC, either for optimization or for monetization, you'll be able to do a lot of these testing and validation of this app before you put them in the real network. So, including geolocation, traffic steering, load prediction, all of these different apps you'll be able to actually validate them using real data, and then, take them to the next step and install them in the real network. So this also opens up a new concept. Since now 5G will become more of a software, the idea of a 5G digital twin, which means, you can build exactly the same 5G network that is running in the field and running in real time, and build a twin of it that is based on emulation and copying data from the real network and emulating them in the digital twin. This will help from different ways. One is you can test new ideas, new optimization ideas. You can open up for verticals if they want to innovate new ideas and innovate a new vertical. They can actually test it on this digital twin, understand if the app is performing, can it scale, is it impacting other services there, how is your security, you're doing testing all of different security breaches if there is there, and also understanding latency capability. So this concept of digital twin is something that is coming out from all of these emulation and testing scenarios, and also opening up a platform for app developers to look at that. So this is, a quick summary of where we're seeing 5G maturing, the whole concept of openness, the software part of it, and how this is going to be really enabling for new verticals and new ideas. The best ideas I'd say out there is the one that we don't know yet. And these will be the platforms to enable such new ideas. So thank you very much. I hope this was kind of informative of where Viavi sees the maturity of 5G and Open RAN market. Thank you very much.
Wonderful. Thank you so much, Dr. Sami Yamani, CTO of Viavi Solutions. And of course, thank you to all of our speakers and panelists today. As always, before we close, a special thank you to our partners for making this session possible. Today's sponsors included Ericsson, Viavi, and of course, Robin. Right, well, we're going to move right along to our next session, which is going to start immediately after this one. We're going to be hearing about Open vRAN with Marvell, Dell Technologies, and Vodafone in a panel hosted by Stefan Thurau from LightCount Research. So you should be directed automatically there. So you just have to sit back and enjoy the next session. Until then, thanks for joining us.